In this session, we're going to look at a really nice feature of C that allows us to define our own data type based on existing data types. So as I mentioned, the typedef allows us to create our own data types, and it's very simple to do. We're going to start with the keyword typedef, then we're going to identify an existing data type. So that would be character, integer, floating point, strings, structures, those kinds of things. And then we're going to give it a new name. It's pretty common, although it's not required, to give that new name, to put it in capital letters, just to identify it as something that's unique, but it's not necessary. So let's take a look at a couple of examples. So our first one here, we start with the keyword typedef, and we're saying I want to make that an unsigned character because I want to be able to use bytes. I'm doing something where I want to refer to something specifically as a byte. I don't need any more space. I want to limit it to only 8 bits of information, and a character does that for us nicely. But if we say unsigned character, then we know all of those 8 bits are going to be used specifically as would the bits in a byte. So those of us that are working in the embedded world, having a typedef for byte is a pretty useful tool. Let's take a look at another one. So this second one is another one that you'll see often, and this is defining a string type. So here we haven't talked about pointers specifically yet, but what this is saying is a pointer to a character, and that's a pretty common way to use strings. So here my data type that I've just declared is called string, and it's going to allow me to store strings. Now when I use that, if we come down here to the bottom, it's important when we define a string this way with a pointer that we're actually fixing some strings. So we're making it a constant value because we haven't actually reserved space for that until we do something like this. So we have my string data type. I'm saying const in front of it, means it's not going to change. It's called string, and it's going to be assigned the characters some text. My byte definition here, I'm going to call it input switches. I'm going to get some information from some switches that are going to come in through a port, and I'm going to assign those to something called input switches, and it's going to be only 8 bits long, which would correspond nicely to the switches that I have. Where typedefs come in really nicely is when we are using structures. And what it allows us to do is when we define that template for our structure, we can use a typedef with the keyword struct, so the two keywords together, and then give that data type a name. So what we're going to have inside our fields, same as we did before, they're going to have our standard data types, or it could even be a typedef that we've done before. But now we're not reserving memory. We're saying this is going to be a new data type. So let's take a look at our example. There are my two keywords, typedef and struct. I have the same fields I was working with in the date example that we used in the structures video. And now my data type is going to be date. Again, I put it in capital letters to indicate it's not a variable, it's actually a data type here. Now in order to be able to use that, I'm going to use my new data type and give it a name. So capital D-A-T-E, followed by the name of my variable, or my structure, which is going to be today. The nice thing about this is before, when every time we wanted to use that structure, we had to type struct. Date was the template that I said before, and today, well, we don't need to do this anymore. Now we can use our own defined data type.